beginning our review video for Chapter 8, Section 1. Chapter 8, Section 1, and the learning target for today is to use the distributive property to simplify algebraic expressions. So we've covered the distributive property before earlier in the year, but let's do some definitions here. Equivalent expressions, expressions that have the same value regardless of the values of the variables. So equivalent expressions would be like equivalent equations. Term, a number, a variable, or a product of numbers and variables. Coefficient, the numerical factor of a term that contains a variable. So it's kind of the number out front of a variable. Like terms, terms that contain the same variables. A constant, a term without a variable, so that's just a number. Simplest form, an algebraic expression that has no like terms and no parentheses. And the last one, simplifying the expression using properties to combine like terms. So it could be distributive property like we're going to work with today. Well, let's jump in and do one. Use this distributive property to rewrite the expression 3 times the quantity x plus 5. Well, we know from the distributive property that that becomes 3 times x plus 3 times 5. So 3 times x can't be simplified, but 3 times 5 can become 15. So 3x plus 15 is using the distributive property to simplify that initial statement. The next one, use the distributive property to rewrite 2 times the quantity x plus 6. So it becomes 2 times x plus 2 times 6. So 2 times x plus 12 is our answer. And that looks like letter D down here. Moving on, use the distributive property to rewrite a plus 7, the quantity a plus 7 times, a plus 4 times 7. So I'm going to say that is a times 7 plus 4 times 7. Well, 7a plus 4 times 7 is 28, so it would be 7a plus 28. I'm distributing the 7 over both parts of the things in the parentheses. That's our distributive rule. Second example of this type is to use the distributive property to rewrite a plus 6 times 3. So that's a times 3 as I distribute that over the insides of the parentheses, and 6 times 3. So 3a plus 18 is the way this is worked out, and that becomes letter B. Use the distributive property to write q minus 3, quantity q minus 3 times 9, q minus 3 times 9. First thing I need to do is rewrite q plus a negative 3, all right, the whole quantity times 9. So I'm going to distribute the 9 to the q, so it's q times 9 plus negative 3 times 9, so this would be 9q plus negative 3 times 9 would be a negative 27. So now I can go back to a subtraction problem, 9q minus 27. 9q minus 27. Similar problem here, use the distributive property to write q minus 2 times 8. So it is q plus a negative 2, the whole thing times 8. So this is 8q plus a negative 2 times 8 would be a negative 16, which becomes 8q minus 16. 8q minus 16, and that looks like letter C here. Use the distributive property to rewrite the negative 3 times z minus 7. Well, I'm going to go negative 3 times z plus a negative 7. All right. So negative 3 distributed over both parts, so it's a negative 3 times z plus a negative 7 times a negative 3. So negative 3z, a negative times a negative becomes a positive. 3 times 7 is 21, so it's plus 21. All right, negative 3z plus 21. Use that same idea down here. Negative 2 negative 2 times the quantity z minus 4, so it's negative 2 times z plus a negative 4. All right, so it's negative 2z as I distribute that part, and as I distribute this part, plus a negative 4 times a negative 2. So negative 2z, negative 4 times negative 2 is a positive 8. So it's a negative 2z plus 8. Negative 2z plus 8 is letter A on the choices here. Number 7, identify the terms, the like terms, the like terms, the coefficients, and the constants. All right, well, let's look at the terms. First of all, here are the terms. There's 3x, there's a negative 5 is a term, plus 2x, or drop the plus. 2x is a term, and negative x is a term. 1, 2, 3, 4 terms. Like terms, so like terms are equal to, well, 3x, 2x, and negative x. See, this should become a plus, a minus x here. So it's a negative x, are all like terms. The coefficients are 3, 2, and negative 1. The negative 1 comes from right there, negative 1. And the constants, well, there's only one constant, and it should be actually plus a negative 5. So a constant is equal to negative 5, negative 5. All right, so let's do the same thing down here at this example. Let's look at terms. I've got 6x. I've got plus a negative 2. I've got plus x, and I've got plus a negative 4x. Those are my terms. So if I look down here, I've got x. No, it doesn't work for this one. Here I've got 6x negative 2. That looks like it works. X works, and negative 4. So far, that one checks out as a possibility. And I've got 6 minus 2x and negative 4. This one checks out as a possibility. And D down here, 6, this one also checks out. So it's going to be one of those three. Let's look at like terms here. Like terms. Well, the 6x would be a like term, and the x and the negative 4x would all be like terms. So let's check out the next one. 6x, x, and negative 4. So that one checks out. 6x, x, and negative 2. So this one does not check out. Let's check D here. Like terms 6x, x, and negative 4 checks out. So it's either B or it's D. Let's continue on and look at the coefficients. The coefficients is 6, 1, and negative 4. 6, 1, and negative 4. Coefficients 6, 1, and negative 4. So B is still in the running. 6, negative 4, and negative 2 are not. So I'm thinking it's going to be B here. Let's look at constants just to check. If I look at the constants, it should be a negative 2. This one checks. And this constant does not check. So the answer is truly B as we check out all of the different parts. Simplify the expression 6n minus n. Well, I'm going to write 6n plus minus n. And really it's 6n plus a negative 1 as my coefficient times n. And I'm going to undistribute. In other words, I'm going to do the opposite of the distributive property. I'm going to factor out the n's. So I'm going to say 6 plus a negative 1 times n. So I'm pulling the n back out. And I'm saying here it would be 6n times a negative, or plus a negative 1n. But pulling it back out, I've got 6 plus a negative 1 times n. Well, I can simplify this part. 6 plus a negative 1 is 5. So my answer would be 5n as I simplify that. Down here, simplify the expression 7n plus n. 7n plus 1n. 1 is the understood coefficient there. I'm going to factor the n back out. So I'm going to say 7 plus 1 times the quantity n. 7 plus 1 is, of course, 8. So it would be 8n is my answer, 8n. And now, simplify this. First thing I'm going to do is change all the subtractions into additions. So I'm going to say 8z plus z plus a negative 5 plus a negative 9z plus 2. Same expression I just went through, and that was by the definition of subtraction. Went through and changed those. Now I'm going to collect the like terms and the constants. So I've got 8z plus z plus a negative 9z. Those are all like terms, plus a negative 5 plus 2. Those are the constants. I'm going to factor a z out of this. I'm going to put a z out in front, and it becomes 8 times z becomes 8 here, plus 1z, because z times z would be 1z, plus a negative 7 is how I factored out that z out of all of those, and a negative 5 plus 2 becomes plus a negative 3. So 8 plus 1 minus 7, 8 plus 1 minus 7 would be 9 minus 7, or 9 plus a negative 7 would be 2. So this becomes 2z minus 3, and that's in its simplest form. All right, let's look at the next one. You might want to stop the video and practice this and see if you can do it. But I'm going to rewrite it. I'm going to say 6z plus 1z plus a negative 2 plus a negative 8z plus 2. I'm going to collect all the like terms. So I've got 6z plus 1z minus 8z plus a negative 2 plus 2. All right. Well, these are all my like terms with the z in it. So I'm going to put a z out in front. That's going to leave me with 6 times z would leave me with just 6. Z times 1z would give me 1. All right. And 8z would give me a negative 8 plus a negative 8 here. Sorry, plus a negative 8 here. And then negative 2 plus 2 was 0. All right. So I've got 6 plus 1 is 7 minus z minus 8 would be a minus 1 times z plus 0. So minus z plus 0 is just minus z. And looks like answer A is our correct answer. Tickets for the school play cost $5 for adults and $3 for children. The family has the same number of adults as children. Write the expression in the simplest form. Well, I'm going to say, let's let X be the number of tickets sold for adults. So for adults, it would be times 5, $5 per ticket, so 5X, plus the number of tickets sold to children, which also is X, times 3, and that's going to equal the total cost that they spent. Well, here I've got like terms, so I can combine them, factor out an X. I've got X times 5 plus 3, X times 8, or 8X is the amount of money they spent for the tickets. Similar problem here. Museum tickets for the museum cost $10 for adults and $7.50 for children. A group of people have the same number of adults as children. Write an expression in simplest form that represents the total amount of money spent on tickets. Well, I'm going to again let X be the number of adults, so it's going to be 10X. To that, I'm going to add the number of children, which is X. They told me it's the same number, times 750. All right, and that'll be the total amount spent. I'm going to factor an X out. X is X times 10 plus 750. So X times 1750, or 1750X, is the price we paid to get into the museum. And that looks like it's letter D. It's cut off down here a little bit, but it looks like it's letter D. All right, thank you.